Hi, and welcome back to our channel Neurabytes. My name is Navjinder Virdee, and in this lesson, we will finally train our function f of x to fit our dataset. So, in the previous lessons, we analyzed our dataset and we found that the relationship between x and y was linear. Therefore, for forward propagation, we used a simple linear equation in terms of x for our function f of x. Here, w and b were our trainable parameters. Then, we defined our cost function, which was mean square difference between the actual value y and the predicted value f of x. Then, we implemented gradient descent for backpropagation in order to train our parameters w and b. It was nothing but taking partial derivatives of the cost function with respect to our trainable variables. And finally, we update our parameters by subtracting learning rate times the derivatives from our original parameters. Now, we are going to combine all these components and train our function f of x. Now, let us write the code to train our function f of x. Firstly, we need to define parameters dictionary to store the values of w and b. Initially, we will assign small negative random values to both these parameters using the NumPy library. We will also define an empty list to store the loss in each iteration. Now, we will iterate over the same 4 steps again and again, and in each iteration, we will update our parameters w and b until the cost function is minimized. The first step is forward propagation. We will use the parameters and the training dataset to make predictions. The next step is to calculate the cost. This cost is going to be between the predictions and the true labels. Next, we will append the cost in the loss list, and we will print the iteration number and the cost for that particular iteration. Now, we will use matplot library to visualize our function f of x. We will plot the function for every iteration to get a good understanding of how our function fits the dataset. So, the next step is backpropagation. This is the most important part in any machine learning algorithm. From this step, we will get our derivatives, which we will use to update our parameters in the next step. So, the last and the final step is to update the parameters. We will use the derivatives that we derive in the backward propagation. And finally, we will return the trained parameters and all the loss. The only thing left is the actual training. we will use 0.0001 as our learning rate and we will iterate over for 20 times. Here, orange represents our function f of x and the blue is the actual dataset. Initially, the predictions are random and our loss is very high, almost near to 6000. After the first iteration, our loss has decreased and the curve is slowly moving towards the actual dataset. As the number of iterations are increasing, our loss continues to decrease and our function f of x is slowly moving towards the actual dataset. Now our loss is almost near to 130. Now our function seems to be very close to the actual dataset and our loss is almost near to 4. And here we go, we have perfectly fit our dataset. So as you can see, we started off with random predictions with the loss very high, and with the iterations going on, we keep on updating our parameters and in the end, we actually fit our dataset perfectly. From 6000, we decreased our loss to almost 4. Now we have trained our parameters. So let's check and verify whether we are able to generalize the dataset using the validation dataset. We will use the parameters to make predictions for the validation dataset. Again, we will use matplot library to visualize the validation dataset and our function f of x for the validation dataset. Again, as you can see, we have perfectly fit the validation dataset as well. This implies we haven't overfit or underfit the dataset. Again, let's verify using the cost function. So our cost function is again near to 4, which again implies that we are able to generalize. We haven't overfit or underfit the dataset. So here we go. We have implemented our first machine learning algorithm from scratch. Congratulations that we have implemented linear regression with one variable from scratch. And in the next lessons, we will start with another algorithm and again we will implement everything from scratch. Thank you for watching these videos. If you liked the video, then please like, subscribe and share. And I'll see you in the next lesson.